Hey, good morning, pre-calc. So I've got good and bad news. Good news for you, this is the final new thing that's going to be on our chapter test coming up this Friday. The bad news is, of everything we've learned, it's probably also the most difficult so far in this chapter, okay? But I think you guys are capable. Just make sure you follow along with me. If you need to rewind it and watch it again, you can. Tomorrow we're going to be reviewing the same concepts, so you guys get a chance to have some questions with me. And then Thursday will be our chapter review, and Friday will be your opportunity to start the test. So today we're going to be talking about how to graph and write the equations of circles. Okay. So first question for us is, what does this equation of a circle look like? And our equation of a circle is going to always have an x component that's squared and also a y component that's squared. And then the two of those added together will equal whatever our radius squared is. Okay, so in this case, the center of your circle will be found at the point HK. Notice we get the x value from the x parenthesis set, the y value from the y parenthesis set. Both of those are opposites in the equation. Okay, so you might want to make a note that to find your center, you're going to change the signs for HK. Okay. And once again, remember, that doesn't mean that your center is always at positive points. It just means whatever it is, it's the opposite of what it was in the equation. Okay. And now your radius, so the distance from the center to the edge of the circle in a straight line, is going to be equivalent to r. Notice in your equation you'll have r squared. Okay. So we look at this first problem. X minus 5 squared, that quantity squared, plus y plus 2 quantity squared equals 9. So for this one, let's start by finding our center. So we look at the x value of our center, will be the opposite of whatever's in there. So it was negative 5, so it's going to just be 5. Our y value, the opposite of what's ever in there, so it'll be negative 2. Okay, so we can go to that point. From 0, 0, we go right 5, down 2, and we get a center point. Okay, now this one is important. To find our radius, remember, it's the square root of whatever's there, because we just need r, and that 9 is r squared. Square root of 9 in our case is going to be 3. So now to graph it, I can simply count from this in straight lines to the left, to the right, up and down, and put some dots. So down 3, right 3, up 3, and left 3. And all we got to do is draw it in and try to make it as circular as possible. Obviously, my picture is not perfect, but we should have a circle shape there, okay? And you'll get better at drawing circles as we go. So now, example 2 over here. Same idea. We want to start by finding the center. So the center will be the opposite of this x, so it was negative 4, so it's going to be at 4. Now the y doesn't have anything there. So essentially it's y minus 0. That's the same as y minus 0 squared. Nothing changes, so we'll put a 0 here. The radius in our case is going to be 5, so we start at the point 4, 0 here. Our radius is 5, so we count 5 to the right, put a dot. 5 down, put a dot. 5 to the left, put a dot. 5 straight up, we put a dot. Then we draw our best circle in. And obviously, mine kind of looks squarish. It should be more circular. Hopefully over time, I'll get better at it. You'll get better at it. But we want it to be circular in shape. Okay. But I will give you grace because I'm seeing as I'm drawing with my stylus, it's tough. And I understand. It's hard to get a perfect circle, but we want it to be as close as we can. So now, if we look down here, example 3, we want to write an equation. Here's what h and k are, okay, and it tells us the radius is 2. So if we plug those in, we know it's going to be x minus h, which in our case is 5. We'll square that, plus y minus 8, y minus k, which in our case is a negative 8. So y minus negative 8 becomes plus 8. We'll square that, equals r squared. In our case, r is 2, so 2 squared gives us 4. Okay, so take a moment and try example 4 here. All right, since our x value is 0, we don't have to put anything with that. It's just x squared plus y minus 3, and we'll square that, equals, now be careful here, the square root of 3 squared. If we square that, those two cancel out, and we're left with just 3. So now, on this 5th example here, we want to write an equation based on this one. We don't know what the radius is, we don't know what the center is, but we can look and observe. So the center is pretty easy to see. 2, 1. It's right in the center there. So if they give you a point somewhere in there, we're going to assume it's the center. I won't throw in a point that's like a little off. Yeah, I won't try to trick you. This is just about, can we figure it out now? So we'll start off with the first part of the equation, and we know it's going to be x minus 2 quantity squared plus y minus 1 quantity squared equals. Now, if we look here, that point 0, 1, this is a point 2, 1. They have the same y value. It moves over a distance of 2 here. So we know the radius is going to be 2. So we do 2 squared, which gives us 4, just like on example 3. All right. So go ahead and flip it over to the back of the notes, and here's where it starts to get a little bit more tricky. Okay, so here they tell us there are endpoints of the diameter at 4, 3, and 0, 1. So if these are our endpoints, we can start by plotting them. So 4, 3, 0, 1. Now we know that these are our endpoints, which means our center has to be halfway between those. So down 1, if you look at it, down 1 over 2, down 1 over 2, it'll be right in the middle of those two. Okay, the center, another word or way to think about that is our midpoint. Okay, now we know that our midpoint has to occur halfway between them, so at the point 2, 2. So our midpoint or center occurs at 2, 2. Now we have to be careful. Our radius, another way to think of that is just a distance, okay? So it's also known as a distance. The distance from the edge to the center in a straight line. Now in our case here, the distance from here to there, notice we can use our Pythagorean theorem method. Okay, so we got 2 squared plus 1 squared equals c squared. And that distance, or our radius, will then be 4 plus 1 equals c squared. So we'll get 5 equals c squared, and that distance, the square root of that. So our distance, or our radius, is going to be the square root of 5. So now, we have enough information, and we can write what our equation is. So we'll start always the quantity x minus, right here, 2, and we'll square that, plus y minus 2, and we'll square that, equals whatever our radius is squared. Square root of 5 squared would give us just a 5. All right, 2 more examples. I know this is where it gets a little bit more difficult, but example 9 here. The center is at negative 3, 1. So we already got the center, negative 3, 1. And it tells us that it's tangent to the line x equals 1. Now, if you don't know what the word tangent means, it means if we have a circle, the line that's tangent to it runs right beside and just barely touches the circle at one specific point. Okay? Doesn't cut through it, it just barely hits the side of it. So if our tangent line is at x equals 1, let's first graph that. So we go to x equals 1 here, and it will be a vertical line. Notice every point along that line is where x is equal to 1. And we know it's tangent to that, so it has to come over here. So that radius is, hopefully you can figure this out. The radius, if this is the center, would be 1, 2, 3, 4. Okay, so our radius equals 4. Now I can go 4 down, 1, 2, 3, 4 down, 4 left, 1, 2, 3. It's going to go a little off, is 4. And then 4 up, 1, 2, 3, 4. All right, then we draw in our circle. And man, I still am not very good at drawing circles. So give me some grace. I need to continue to practice drawing circles on this touchpad because it's not going well. But we have enough information now. We can write our equation. So we'll start with the center here. It's always x minus, and the opposite. So minus negative 3 becomes plus 3. That quantity squared plus y minus 1 squared will equal whatever the radius is squared. In our case, 4 squared gives us 16. All right, one more to look at. And once again, this one, we know the center and we know the point. We don't have a graph here, but it might help you to kind of visualize. If we had an xy coordinate, the center is over here at 13, 12. The point 15, 16 is going to be right 2, up 4, and that's where 15, 16 will occur. Okay, this point was 13, 12. So if we think about it, that to find that distance, to find our radius or distance, we can use the Pythagorean theorem again. So 2 squared plus 4 squared, all that added together will equal c squared. We get 4 plus 16 equals c squared. 20 equals c squared, and so the c, or that distance, is the square root of 20. Okay, now our center we already know is given to us right there. So to write our equation, we just do the quantity of x minus, right here, 13 squared plus the quantity y minus 12 squared will equal, if we take the square root of 20 and we square it, this will cancel out. We're left with 20. Okay, so I know this backside was kind of difficult. Tomorrow I have built in as kind of a review day. We'll talk about circles again. Be a little bit more work for you to do, but you guys should most likely be at school tomorrow. So I'll be able to kind of explain it in person. Bring any questions. Still try today's review, but if you don't quite know how to do it and can't submit it until tomorrow, that's fine. Hope to see you guys tomorrow at school, and hope you have a great day. Bye.